In this video, we will discuss the engines and fuel system for November 7261 Yankee, November 84 Juliet Sierra, and November 87 Charlie Whiskey. The twin Comanches have two Lycoming IO320 engines. They are 160 horsepower, have a 2,700 RPM limitation. Each engine has 4 cylinders. They are air-cooled, normally aspirated, direct drive, and fuel injected. They take 100 low-lead fuel. They have a minimum 2 quarts oil capacity and a maximum of 8 quarts. As a school operating procedure, we use 5 quarts minimum. Underneath the engine cowlings, there are cowl flaps used to assist in engine cooling. The cowl flaps are open and closed via 2 silver handles to the right of the throttle quadrant. The twin Comanches burn 8.6 gallons of fuel per engine at 75% power. The fuel flow goes from the tanks to the selector valves to the auxiliary fuel pumps, the engine-driven fuel pumps, the fuel servo, the distributor, the cylinders, and then the fuel flow gauge. November 7261 Yankee and November 87 Charlie Whiskey each hold 90 gallons of fuel with 84 gallons usable. The 2 main tanks hold 30 gallons total with 27 usable, and the 2 auxiliary tanks hold 15 gallons total with 15 usable. November 84 Juliet Sierra holds an additional 20 gallons for 110 gallons total and 104 gallons usable. The main tanks on auxiliary tanks in 84 Juliet Sierra are the same as 61 Yankee and 7 Charlie Whiskey. And additionally, 4 Juliet Sierra has 2 nacelle tanks that hold 10 gallons total, all of which are usable. To operate the nacelle tanks in 84 Juliet Sierra, you will first use 1 hour of fuel from the auxiliary tanks. After using 1 hour of fuel from the auxiliary tanks to create space in the auxiliary tanks, you will then activate the 2 silver switches to the left of the prop levers on the panel. Those silver switches activate additional fuel pumps that pump the fuel from the nacelle tanks to the aux tanks. If you did not use an hour of fuel from the aux tanks first, you would pump the fuel into the aux tanks and it would overflow because there would not be any room for the fuel from the nacelle tanks. Each of the planes has 4 fuel pumps to get fuel from the tanks to the engines. Those are 2 engine-driven fuel pumps and 2 auxiliary fuel pumps. The auxiliary fuel pumps are for redundancy. They are used for priming the engine during takeoff, landing, anytime we are switching tanks, and in the event of an engine-driven fuel pump failure. You have a fuel selector for each engine on the airplanes. In the top photograph, when the fuel selectors are pointed out, that is the off position. If you move the fuel selectors so that they are pointed up and out at a 45-degree angle, that is the auxiliary tank position. If you position the fuel selectors so they are pointed up and in at about a 45-degree angle, that is the main tank position. And if you pointed them directly in, that is the crossfeed position. The point of crossfeed is to extend a single engine range. If we were to crossfeed, we would position our operative fuel selector to the crossfeed position and our inoperative fuel selector to whichever tank we wanted to take fuel from. So in the event of a left engine failure, if we wanted to crossfeed from the left side of the airplane to the right engine, we would put the right fuel selector on crossfeed and the left fuel selector into the position that we wanted to draw fuel from. And if you have any questions, don't hesitate to reach out to us.